Thanks everyone for coming and joining us. I am going to introduce our speakers today. So first of all, we have Professor Matt Lease. He's a professor of School of Information, the co-director of the CosmicAI Institute, and he's peer-reviewed. So when I say that, that is kind of literally correct because he has a series of, peer-reviewed honors, including the senior member, distinguished member of the ACM, a senior member of AAAI, and he's the founder of UT's Good Systems, and very big number of Best Paper Awards, and I think multiple.
I've done stuff.
Multiple Test of Time Awards. Okay, so should I introduce Ho-Jung now?
Let's do it after everyone.
Yeah, sounds good.
We have to set up anyway. So.
Yeah. Okay.
Hello, everyone. Thank you so much for coming. As my title said, I'll be talking about responsible AI for science, talking about benefits versus risks. So as some of you saw, I wanted to start with telling you about 5 reasons to hate this talk. I don't have enough time to really do it justice, so it might be a little bit rushed. I'm going to say some things that are bad about AI, so if you just love AI, you're not going to like that. I'm not going to tell you how to solve problems, I'm just going to talk about problems. I have to run to teach after this, and so I can't actually talk much after the talk, but feel free to email me to discuss later. You might also hate the talk if you don't like Yogi Berra, because I have some wisdom of Yogi Berra. So briefly, I'll talk about what is AI for science, what is responsible AI, talk about some potential benefits, why people are excited about AI for science, some potential risks that we should be thoughtful about, and then, like I said, hopefully a little wisdom of Yogi Berra to send us on our way. Okay, so a year and a half ago, we launched this CosmicAI Institute, which we were all very excited about. Jane did a nice press release, and I got a quotation in it where I said, I'm particularly excited by our focus on new generative AI capabilities to accelerate discovery. So what was I talking about? Say a month before, for example, let me hide these controls one more time. They reappeared on us. Let's see, here we go. Like say the previous month, there was this AI scientist paper sort of giving you this idea that we decided to do science from start to finish entirely through AI automation. So really transforming everything that we thought we had to do through traditional scientific practices. So pretty cool stuff. And just last week, the VP of Science for OpenAI said 2026 will be for AI in science what 2025 was for AI in software engineering. Very bullish. We're really going to see lots of advances. You're going to see companies are making big bets, lots of investments across this space. So a lot of stuff is happening. So this AI stuff is cool, full speed ahead, right? That's what you should think. Well, not full speed ahead if your autopilot is driving. And maybe don't trust the fake images that AI put online. Or don't trust it for your healthcare, and don't talk to the chat bot or the Face ID, because it might actually be somebody in Congress that we think is a criminal now. So lots of mistakes, lots of problems we've all seen with the rollout of AI technologies in every area by every company. So this stuff is fraught with peril. Lots of problems can happen. Okay, so what do we do now? Do we just write death poetry because AI is bad? Let's try to do a little better. So I want to talk about responsible AI. So our university president, former university president, Greg Fenves, back in 2019, launched a university-wide initiative called Good Systems, trying to think about responsible AI. And the idea is to ensure that the values of society drive the design of the AI technologies we're creating. So there is this large campus-wide initiative called Good Systems. We're in year 7 of 8 right now. We have over 30 departments on campus engaged, over 130 active researchers engaged, where we're just basically trying to say, how do we get as much of the good with the least amount of the bad? How can we maximize the benefits when we use AI technologies and prevent the risks? The other term you'll hear people talk a lot about is AI governance. Same kind of thing, all kinds of things that we govern, which we're trying to make sure, again, we do in reasonable, thoughtful, reflective ways. How do we use this in a way that's going to harness the good of it for it, and sort of take into chance, things that might go wrong, privacy, security, blah, blah, blah. So this is the kind of stuff we're talking about when we talk about AI security, responsible AI. So let's talk about potential benefits of AI for science, the things that we can be pretty excited about. Okay, accelerating scientific discovery. This is like the #1 catchphrase everyone talks about. So we want to improve the efficiency of scientific work, how fast we can do it, the scale that we can get done, how easy it is to do science, while ideally also using fewer resources. So we can have more and it even costs less to do it. That's the dream. So when the National Science Foundation did the press release for our institute, they talked about that we're going to accelerate time-consuming aspects of astronomy research, such as processing and analyzing data, creating simulations, etc. So it sounds great. There's this other thing, which I think there's so much focus on efficiency. I think it's really important to actually just talk about quality for a little bit. And I'm just calling this expanding the discoverable. So what are some things you could do that maybe we couldn't do before? So how about exploiting knowledge of all prior work? So everything that's ever been written, and maybe even the thing that got published on arXiv 3 seconds ago, that the AI can already scan and read. So the idea is you can really, really track more than our brains can keep track of what's happened out there and potentially incorporate it. Along with this, we don't publish negative results because boo-hoo, who wants to hear about those? But AI can be potentially, every time it tries something and it doesn't work, logging it and learning from those negative results instead of just the positive ones. If we really wanted to share them, we'd still have a way to we'd have to have some kind of database and a motivation to share our negative results, but at least we can potentially really learn from them in a robust way. We can explore, again, ideas and models of complexity beyond what our little wetware brains can deal with. So often we choose things like Occam's razor, the simplest thing is best, but that's somewhat a function of our limited cognitive abilities. Maybe we can really explore much more complex ideas and models than we could just because they weren't biologically possible for us. Really new and fresh perspectives. Again, we're used to how we people think about things. Maybe AI can bring some really different perspectives and vantage points to the stuff we're doing. Mitigate biases. We're all biased. Sorry if you didn't know that. We all are. And AI comes with a different perspective. There's lots of talk about AI bias in responsible AI. Just get ahead of myself. But people have biases, and it is something that potentially we can mitigate through some forms of automation or technology. Now, enhancing transparency and reproducibility. A lot of times when we're talking about these black box AI models that are more powerful but more opaque than ever, we think we really have to give up transparency. But in the class I'm teaching this semester, for instance, we've already seen examples of work that's being done, which is actually better documenting stuff, really keeping track of the full provenance of everything from start to finish, of how your experiment was done, how every number in the paper got generated back to the code and the data that it worked on. So potentially we can actually have more about the chain of reasoning, the chain of evidence that went in to support the transparency of science. What about living lit reviews? So, okay, a year ago, some guy wrote a literature review on something that's kind of related to what I'm interested in. Too bad it's not up to date. Too bad it's not what I really want. Wouldn't it really be better to have a literature review that I can, on demand, get for anything that I want that will always be current and personalized, tailored to my personal interests? The next 2 points, this slide and the next one, really relate to access. So machine translation is one of the great successes of modern AI. And it's really become much more of an engineering problem than a science problem in so many ways. And so the idea is that you can translate all scientific writing into all language on the planet. So from an English perspective, you can think about translating all English science work, the latest thing that happened 3 seconds ago and everything in history, into every other language in the world, so that people can read in, their scientists in other parts of the world can read in native languages, stuff that's happened. You could translate all non-English science work, recent and historical, into English. Hey, for those of us who speak English as science, it turns out other people in the world are also doing science. They don't always write it in English, so it would be nice to know about that. We would like to make stuff, science available for universal access, for policymakers, for journalists, for practitioners. Wouldn't it be great, again, across the entire world if just everybody knew what was going on? And we'd love to rewrite all science articles for many different audience segments, for reading levels, for different contexts of use. You can take an article and quickly make 30 different versions of it for different audiences to make it the most accessible, usable content for everyone. We'd like to democratize science. So can we further lower barriers to participating? For instance, anyone can access GPT or something online, your favorite large language model to do something. Is it that easy now to do science that you just open up your web browser, go to your favorite large language model, and suddenly we can empower you without needing collaborators or professors or things like that to start making real science contributions? Can we assist new people in getting started? 24/7 available online AI assistants and personal tutors to help you start getting engaged in science. Zero code scientific programming. You just say in natural language what you want and the code generates it. And, just as we saw earlier, 2025 was a big year for AI generating code automatically. I hear from lots of people, academia and industry, how it's really transformed the process of code writing. So more and more now, we can really sort of make it easy to access all your different data sets, generate code, through English. And again, our National Science Foundation press release a year and a half ago, we will democratize access to data analysis by powerful AI assistants that provide accurate responses. So again, this is the dream, what we want to do. Okay, that all sounds great. Now let's talk about some of the other stuff. First, what I'm calling good problems. Okay, so if we need AI to do science, then scientists suddenly need to know AI and not just astronomy and chemistry or whatever else, your discipline is. So I think we need to think about how to try to do that. In the CosmicAI Institute, we have a certificate program of trying to help astronomers learn more about AI. But in general, this is going to be a problem across fields for thinking about how to do this, how much AI people need to know to be successful. And then we have scaling challenges. So let's imagine all of us are now amazing scientists and we're all writing 1,000 papers a day doing all of our great science now with AI. How is peer review going to deal with that? How are we going to keep track for writing our literature reviews or related work sections of understanding what all is happening? There's the logistical, practical issue of just keeping up. But emotionally, I always have students or peers talking about the anxiety, the stress of this pressure cooker of always having to know what's going on all the time. It's not going to get easier. How are we going to emotionally manage that so we can be healthy scientists? The paradox of automation. This is this thing that sort of surprises people. As AI gets better, as automation is better, it turns out humans are more important. What's that about? So as AI is more efficient, human oversight becomes more crucial because fast compounding errors can have severe cascading and financial consequences. The more AI does, the faster it does it. If there's any mistake, boom, you just had 1,000 mistakes happen if you don't have somebody catch that along the way. As AI errors become rarer, you're much more likely to miss them. And so in addition to the general problem we have of automation bias, where people overtrust AI systems in general, as it becomes rare, you more and more tune out. That's how the Tesla driver using autopilot didn't pay attention and his car crashed because the time that he was supposed to be providing an AI review oversight, he wasn't, right? So yeah, I don't want to belabor that point further. Even when automation is feasible, what turns out is often in practice, it's more efficient, practical, and safe to have human workers. There is a strong narrative from Silicon Valley, from the journalist who wants to have a sexy story, that's always about AI is doing this and how amazing it is, great science fiction story. And almost always behind the scenes, people are actually underpinning the thing to make it actually work. The last mile is almost always human work, and it's often devalued, hidden, and put away such that you don't think about it or know what's necessarily going on, but it often is propping up the automation in practice that you might take for granted or think is being automated. So accuracy is paramount in science. We think about the quality of the work we do. We think about people trusting us because of the quality and reliability of the work, the reputation that we have for the work. This is each piece of work we put out, and overall trust in science as an institution for the public, the individual reputation, for all of us. People are fallible. If you thought you were perfect, sorry to pop your balloon, you're not. But we pretty well know how we're imperfect, and we have a lot of processes established to deal with this in a robust, known way. AI tools are new, and any change, any new process is rife with opportunities for errors. In his case, we have opaque AI systems producing plausible, difficult to verify outputs with unexpected forms of random error and all kinds of systematic bias. So now we have to think about AI errors, we have to think about human errors, and we have to think about when AI and human come together, their interaction errors. So this is one of the main things, like why experts, lawyers, doctors, anyone, scientists, journalists, are reluctant to adopt automation and AI is often because of this lack of control and risk of the error it's going to introduce, or something where we think quality is paramount. Erosion of our abilities to think or do science. There's what's this phrase called cognitive debt. The Daily Texan even had an article about it not long ago, that we've seen in various studies, long-term degradation in critical thinking, memory, and analytical skills from increased reliance on AI. So the more we use this stuff, the less we might be able to actually do good science on our own. The more that AI acts as an intermediary that sort of separates us from science or the hands-on work, the more that we become distant from it. And that close connection, that intimacy with our field and our domain might be important to some of the things that help us to understand the field we study and work in it. If I need to put out a grant proposal tomorrow, let's say, and I have no time to produce it, AI might help me generate something really fast. Very short-term gain, I can do that. But I'm probably not going to learn much when it generates a 30-page proposal for me. So we might need to think flexibly about how is it that when we just need to generate lots of stuff quickly, maybe AI can help us do that fast. But if I'm really interested in learning, in skill growth, in retaining what I learn, I need to be much more of an active participant in actually doing some of this hands-on work as part of the process. Emily Bender is one of a number of people in this great PNAS article sort of talking about different viewpoints here. And she says, everybody who talks about automated science writing is amazing so scientists can get back to the real work of doing science, don't understand the role of writing in the scientific process. Writing is sort of fundamental to how we formulate, organize, refine, reflect on our ideas. Personally, I often figure out what I think about something as I write about it. So if we just automate all that away, you're actually automating away part of what's really crucial to science work. Writing gets talked about a lot because that's sort of the most obvious application of these LLMs, but this is sort of more general principle. Okay, scientific diversity. So one of the things that we may think that science works really well is just, so we got thousands, a million universities around the world with a billion scientists all doing different things because you are all creative, beautiful, unique people who think in different ways. Similarly, if you just think about the industry ecosystem, we talk about 10,000 garages, where everybody has their own unique ideas. They're coming things from different ways. That's how innovation happens. There's ecological diversity of the system. Now, if everyone just starts adopting the similar foundation models and asks them what should I work on, or do my work for me, what we could expect to see is a lot more homogenization, loss of this really valuable ecological diversity in how we come up with ideas or hypotheses, how we choose our research directions, the methods we choose to approach our different problems. This is again, real risk of losing what really comes with the wisdom of crowds, collective intelligence. It's that diversity of everybody coming at things from different perspectives that really makes stuff work holistically, globally. Has anybody heard about AI as a hot topic? Or has not heard about AI maybe 100 times already today? So if you put all your cards in AI, you're making a resource choice to focus on that more than other things. So for instance, funding an AI Institute for Astronomy is choosing not just to put money into astronomy and asking astronomers, what do you think are the most important problems in astronomy that you need to tackle? We're sort of biasing things like funding decisions. We might choose to pursue AI-related research, funding calls, or as individuals, because it's more likely to get funded, more likely to get accepted in peer review, more likely to be cited, because it's the cool kid on the block. And if you're not doing AI, nobody cares about your work. As much as we like to think about AI democratizing access, it is compute intensive. There is skill training required. And all the resources that go into doing this AI stuff are getting diverted away from other things that might actually be more important. This is a judgment call, but I'll come back to that because that's an important thing. AI suggesting suggesting or deciding which research directions to pursue. So I showed that AI scientists at the start, from start to finish, it pursued an entire project. It chose what it was going to work on. Certainly, if AI is automating choice of what to work on, it's definitely setting directions for us. But even if it's just suggesting, what do you want to work on today? Do you want to think about your own idea? Or I'll just suggest 2 or 3 and you can pick one of mine and work on that. So again, another thing that's sort of surprising when you think about it is this idea that somehow we would know less. So the epistemic goal of science is to understand our world better. Like forget practical applications, just think basic science. We are curious about our world. We want to understand it. We want to know how it operates. And that knowledge is what enables us to discover and invent new things tomorrow on the practical side. An inscrutable AI model that might make really accurate tsunami predictions is incredibly valuable for society. It's going to save lives from people who might have otherwise, got impacted by that natural disaster. But if we don't learn anything about how tsunamis actually occur or how they function, we're not going to be able to make better models tomorrow, and we're not going to learn, about our world. So we have this trade-off potentially between predictability and understanding. There's always a question about how much we should automate, and we typically approach this through the lens of feasibility. We should automate as far as we can because we'll save work. But think about the role of a scientist. And for those of you who consider yourself scientists, what you love about science. Do you want to have a change in role from being a doer of science to an AI overseer? Do you want to be a human in the loop who just stands by in case AI deigns to ask you to help it with some task it can't do on its own or it's not sure about? So your job is just sort of to be on call whenever AI needs you to do something. Some stuff that's amenable to automation may be joyful, intrinsically appreciated as part of the scientific craft. One of the reasons you went into science to begin with or stay in this line of work instead of going to industry to make more money, for instance. How do we maintain the joy of discovery in science careers as AI's role expands? Human research is governed by various levels of oversight. So even when we think about like fully automating AI, people talk about maybe it should have some bit of human oversight. It's not just like the individual scientist needs to oversee it. Like our universities, our administrative boards need to oversee this research, just like we oversee human research, to make sure we have appropriate protections and safeguards in place, just like IRBs do right now for human research. Last, I mentioned this thing about sort of direction setting. The research directions we choose to pursue reflect societal values or normative values. We used to research things like eugenics, or I remember learning when I was an undergraduate about somebody who was studying, whether or not Caucasians were the most perfect people. And in order to do that, he looked at the skulls of people who died, and by inspecting skulls, decided, yes, indeed, Caucasians were the best people. It was great science. And AI might decide that's a cool thing to pursue. Let's investigate that. Maybe we don't want that. So it seems one of these things is really important for us to have our hand on the rudder or the wheel here of thinking about, one, when we're trying to train AI systems for alignment, aligning them with the values that we really care about. But also, there are certain things about control and agency here we might not want to give up because they're too important to hand off. AI slop is everywhere as people talk about it. There's what the research seems to say about these fully automated systems is if you just let them go, they can produce, C-level science automatically. Great, we can generate a lot of slop. And in fact, this is really hitting our peer review systems hard right now. It's a real challenge for the field, as well as sort of our literature discovery. You can think about how this is impacting metrics we have. Non-archive venues like archive, one is they've had to change their policies to deal with this stuff. Again, it's harder for all of us to use. And I think it's really important to think about the public perception. If the public thinks anything posted online is science, and here's an article that looks like a science paper, just like the one that's published in Nature or someplace else, this is basically undermining the institution of science in society, the potential authority, respect, value, how society views science by seeing all this seeming science out there that diminishes the quality of what we've sort of established through traditional processes. The thing, we love democratizing things. If anybody can produce it, anyone can participate, that's great. But if anybody is producing it, the quality might not be so good anymore. This is sort of the way people critique crowdsourcing historically. I think these were my last two things. I know I'm a little over time. My PhD student will hopefully not hate me too much for talking a little bit too long. So let's talk about more adversarial stuff for a little bit. There are definitely attacks happening on peer review. I was an associate program chair for AAAI, and we saw all kinds of crazy stuff happening, including people having prompt injection attacks. Knowing that we would have AI reviewing, they embedded, code in their papers to try to get by the AI reviewer. I mean, all kinds of crazy stuff. So, generating more citations, basically, that people just can't verify. Generating extensive math, theory, algorithms, where we try, I say like peer review, peer acceptance by intimidation or fatigue. There's so much thing here, you're not gonna be the one to admit you didn't understand that math, or you didn't, you were too tired to go through and do all the checking of the 1,000 theories I gave you. We definitely have seen, again, people generating a lot of parallel submission when this is not allowed, to submitting the same thing multiple places. We've seen people take the same article and paraphrase many versions of it to have more rolls of the dice in the peer review system, to try to, get away with that. And it's amazing, AI is good at generating other versions of figures, other versions of tables, everything to make it really look like a different paper, but it's the same work. Denial of service attacks. This is if you really want to stop science, just dump on the submission systems, tons of crap. So broader malevolence gets talked a lot about, if we make a really good tool for making science happen faster, that means our adversaries can use it too. And our adversaries might use it to build the same things, which we might think are good to build, but we want to build them and not them. But it also could be an issue of somebody building a better cyber weapon or a terrorist attack weapon. And so how do we put guardrails in place to make sure that we're not accelerating things that's really malevolent in terms of scientific production? I lead a project where we're looking at the integrity of protecting the information environment online. We've all seen the rise of things like the disinformation, et cetera. And so one thing, of course, you could imagine is manufacturing false evidence and support for a viewpoint. Oh, climate change isn't real. Look at these 30,000 scientific papers I can now cite showing you that it's not real because I just generated them with AI. But the one that actually happens a lot more is actually just trying to show that there's false debate or something. Okay, so let's say science all says that climate change is real. I'm going to generate 30,000 papers to say it's not. And therefore, look, there's a debate. There's not consensus in the field about this thing, whatever this is. So you create false sense of division. Last thing, as I say, just really discrediting science. And there really is an attack broadly on science right now as an institution, which is if you can't trust it or you can't trust anything else, then I guess just don't ask too many questions and go about your day. So last slide, really. This is just, I'm saying the usual things we always care about with AI. There's a lot of environmental impacts of AI. There's lots of issues of workforce displacement. So if you're going to automate all these entry-level tasks in science with AI, those were used to be opportunities where students could get involved in research. Whenever we have AI, we're looking at shifting and concentrating of power. So this could be industry versus academia, large universities that have the large compute resources versus those that don't. There's lots of bias, and AI is great at learning from us in terms of repeating, amplifying, and accelerating the spread of biases. And there's lots of ownership and liability issues. Hojong actually will say something about this next. But like with AI involved, who gets the credit for a discovery? Or who gets the blame when something goes wrong? How do you think about liability? So this is my wrap up. The wisdom of the great Yogi Berra, who you'll get a sense of very quickly if you haven't. If you don't know where you're going, you might not get there. So we should be thoughtful, given that there are potential risks here as well as benefits, we should be thoughtful about where we think we want to go in charting our course forward. When there's a fork in the road, take it. We're going to think about different directions we can be going here and ones that we think are more likely to lead us to where we want to end up at the end. With that, I will wrap up and maybe take a fast question while Hojong comes up and sets up right now. Questions for me quickly before Jesse introduces Hojong? Yeah, Allison.
Responsible for governance.
Yeah. So at certainly federal, state, international levels, everybody is trying to think about how we can release the power of AI to enable jobs, everything to make our society better, while sort of protecting the rights of people appropriately. So it's happening, of course, at governance level. The industry perspective often is, don't regulate us, we'll figure it out, let us regulate ourselves. So industry folks are thinking about it. Academics are thinking about this and trying to advocate both at industry and at policy levels, how it should happen. So it's something that we think at the highest level, down to when we're training everybody here in AI for science as part of the future, you need to know something about AI ethics so that on a day-to-day basis, you can think responsibly about the decisions you're making.